Improper integral. In this chapter, you will learn how to integrate a function that has a discontinuity. Discontinuity means a function will given in this form. This is called discontinuous function. Okay.
I see.
Okay.
Yeah.
And in this chapter, you will identify which type of function is proper and which type of function is improper. Or you can say which type of integration is proper and improper, right?
Yeah.
Okay. You will also learn which whether an integral is converges or diverges. Diverges means its value coming infinity or minus infinity, and convergence means you will get some constant. Okay. And in this chapter also you will also learn how to calculate improper integral. Okay, let's start. First, we will see what is infinity. Infinity means what? Infinity means a function is increasing towards positive side. Okay.
Yeah.
Okay. Infinity is not a number. Infinity is a symbol which represents a function is increasing without any bond. If it is increasing positively, it will goes to right side. If it is decreasing toward, then it will be minus infinity. Okay, it means that it is going toward left side. Minus infinity represents what? Function is decreasing without any bond. It means that
Mhm.
function gets smaller than every number. Okay.
Yeah.
One
Yeah.
important thing you must know: infinity into zero, infinity into infinity. Already told you how these are indeterminate form, right? 0 upon 0, infinity upon infinity. These are not constant. These are indeterminate form, right? You cannot determine. Okay.
Yeah.
Suppose you want to evaluate this. What the value of x is going towards infinity, then what will the value of 1 upon x square? Then you have no option. You have to put directly infinity in denominator. Infinity square is always infinity, right? So 1 upon infinity. Always remember 1 upon infinity is 0. Okay. So you will get 0, right?
Yeah.
Put here infinity, root infinity. Root infinity is what? Infinity. Okay. Remember two things. What? E raised to minus infinity is 0. E raised to infinity is infinity. E raised to 0 is 1. These are very important.
Mhm.
Okay. Here t tends
Yeah.
to,
So E.
yes,
Sorry.
yes, yes,
E
yes.
raised to minus infinity because it's going like 1/e, the power infinity, just 0.
0. Why? Because when you see the graph, e raised to minus infinity. Minus infinity means you are going toward left side. When you are going toward left side, you will get 0 here. Okay,
Yeah. Just like 0.
right?
Yes.
It exactly you will not get 0, but it tends to 0. It means that whenever you increase the value, decrease the value of t, you will going towards 0. Okay, this is not exactly 0. Limit means that, suppose limit of x tend to fx is b. B is not actual value of fx at x is equal to a. It means that you are going towards b whenever x is going towards a. Okay. You can say as x increases towards a, function tends to b. Okay. You cannot say function is equal to b because when you see the graph, already told you this is f of b. This is f of limit a, right? Okay. What is the limit of sin y? Does not exist. Always remember the limit of sin y does not exist. I tell you why does not exist. Why infinity is not there. Can I delete this?
Actually,
Can I delete all this?
yeah.
Okay. Why the value of sin infinity does not exist? Because let's suppose this is sine graph. For,
Yes.
yes, infinity means what? You are going toward right hand side, right?
Yeah. Yes.
So sometime you are getting positive value, right? Sometime you are getting
Yes.
positive value. After this, you are getting negative value. After this
Yes.
interval, you are getting positive value. It means increasing, right? From -1 to
Yes.
+1, you are increasing. After this interval, you are getting decreasing. So you cannot say when I am going towards positive sign, it is always increasing, right?
Yeah.
Sometime increasing, sometime decreasing, sometime
I'm
increasing,
decreasing.
sometime decreasing. So the value of sin y is not fixed whenever you are going towards right hand side. So its value is
So
does
infinity.
not exist. Yes. If
Yes.
it is always increasing like this, then you can say you will get infinity.
Yes.
If you are going toward left side decreasing continuously, then you can say minus infinity. But sometime increasing, sometime decreasing, sometime increasing, sometime decreasing, this is does not exist. Okay.
Yes.
Similarly, for cos y, this is also does not exist. Why? Because its graph is also same as sine graph. Sometime decreasing, sometime increasing, right?
Okay. So yeah. So the integrate. Yeah.
Yes. ln w. What is the limit of infinity? Ln x. You know ln means log to the base e, right?
Yeah.
Okay. So what will be the value of log x when x tends to infinity? When you see the graph of log, you can see whenever x is increasing, like this, x is increasing, the value of log x is also increasing, right? Infinity will be there. Okay. Yes. One more important thing. Whenever the value of x is decreasing, log x will be 0. Why? Because it will tends to 0. It will approach towards
Yes.
0. This is very important.
So it's open from the right, but it's almost tend to zero from the left.
Yes, because when you see the graph, you can observe that on increasing the value of x, log x become infinity. On decreasing the value of x, log x will approach towards 0 point. Right? Yes. Okay. Whenever this type of function is given, always to common. What common? Take common highest power of x. So when you take x square common, you will get say 3 plus 7 over x square. Okay. X square, when you take common, you will get 5 over x. X square common. Right? Okay. You know 1 upon infinity is what? 0?
Zero plus.
Yes. See, put the value of infinity. Minus infinity square. Right? You know 1 upon infinity is what? 0. This becomes 0. And this is also 0, right? So 3 upon 1 is 3. This is your answer. Yes, 3 is the correct answer. Right? Okay. Last uh, when I was telling you how to find limit of infinity, I told one other method. How? Whenever x tends to infinity is there, always put what? Tends to 0 and put here 1 upon t square, right? You remember?
Yeah, yeah, I know that's fine.
By this method you can also solve. Okay. Do cross multiply, you will get what? 7t square, and this is 1 minus 5t upon t square, right? Upon t square, and this is upon t square, right? T square cancel. Put the value of t, right? Same answer you are
Yeah.
getting.
Space.
Okay. So both
Yeah.
method are very useful. You can use any one of them. You will get same answer, right? This is whenever you are given this type of function, this is called discontinuous function. Discontinuous. This function is discontinuous at x is equal to 2. Why? Because the value of fx is 3x square. When the value of x lies between 0 to 2, right? And same function is becomes a line when the value of x is greater than 2. It means that you can see the value of x is what? Less than 2, less than or equal to 2. When the value of x is less than or equal to 2, this is 3x square.
Mhm.
And this you know, this is a parabola.
Yeah.
So this is a Let's suppose this is 2. Okay.
I see.
Okay. When the value of x less than or equal to 2, this is a parabola. But here it is saying then when the value of is greater than 2, not equal to 2, greater than 2, its value is a line. And you know how to draw a line?
Yes.
I already told you how to draw a line. Put x is equal to 0, y becomes 10. Put y is equal to 0, x becomes 5, right? So 0, comma 2, 5, comma 0. 0, comma, when you put a 0, comma 10, I think here you will get a line. Okay, 0, comma 10. And 5, comma 0, this is 5. When you when you meet these 2 points, you will get a line, right?
Yes.
Okay, but you can see the value of x lies from less than 2. Sorry, greater than
I
2.
see.
Greater than 2
It's
means,
limited.
yes, it starts from here. Okay, and when you combine these two figure, you will get looks like this. Okay, like
And
that.
at point 2, we take the closed one, the closed circle, which is like the value of 2
This
is
is
equal to,
closed. This is closed. Why?
yeah,
Because there is equal sign in this. And this is
I
open.
see.
Why? Because this is not equal to. Okay, right? Okay. Suppose you want to integrate from 0 to 5. So you want to integrate from 0 to 5. So first you will go from 0 to 2 and from 2 to 5. This part you will get. Okay. So this is called discontinuous function, right? Whenever you will go from 0 to 2, the function is discontinuous. So you have to start from here. Okay. This is called discontinuous function, right? Now you can see how we get 0 to 5. See, you cannot go directly from 0 to 5. First you will 0 to 2. And then when the
Yes.
function is 0 to 2, function is what? 3x square. And from 2 to 5, function is what? 10 minus 2x. Okay.
Yeah.
3 is a constant. X square 0 to 2. 10 minus 2x dx. Okay. Integration of x square is x3 over 3. Integration of 10 is 10 is a constant. So 10x 2x square over 2, 2 to 5, right? Put the value of x is equal to 2. And when you put 0, you will get 0, right? Put the value of x is equal to 5. 2 cancel. Right? Now calculate this. 2 raised to 3 is 8. 50 minus 25. 25 minus 20 minus 4, 60. 3, 3 cancel.
8 plus
8 plus 9, 17. So you will get 17 area, right? 17 square
yes.
unit. Okay. Noted?
Yeah.
Okay. What is improper integral? The integral whose value is not defined. It means that when you are getting the infinity or minus infinity, that is called improper integral. Okay.
Mhm.
You can see this. Suppose you want to integrate this, right? You know you can write in this way, x raised to half, right?
Right. Yeah.
X raised to half can also be written as,
And so
yes. Okay. When you integrate, you will get what? Minus half plus 1 upon minus half plus 1, right? Okay. So minus half plus 1 is what?
half,
Half.
which is square root of x.
So you can write 2 root x, 0 to 4, right? Root 4 minus root is 0. Root 4 is what? 2.
Okay.
2 into 2 is 4. 2 raised to 4 is 4. Okay. Yes, 4 is the correct answer. Okay.
Yeah.
Yes. And when you see the graph, this is the graph of root x, and we are integrating this part only, 0 to 4. Okay. So the area of this part will be 4 square unit, right?
Right. Yeah.
Okay. Okay. When the integration of anything, when the integration of any function is constant, constant means other than infinity or minus infinity, then you can say the function is converges. Okay. And the value of any, when the function of each infinity or minus infinity, this is diverges. Okay.
Mhm.
Diverges means what? The function has no bound. No bound means it is
Nice.
continuously increasing toward infinity side or minus infinity side. That's why this is called unbounded function. Okay. But the but when the integration of any function is constant, you can say this is converges. Okay. For example, you can see 0 to 1, 1 upon x. Okay. So you know integration of 1 upon x is log x, right? When you put 1 and log 0. Log 1 is 0, log 0 is infinity. So you are getting what? Minus infinity, right? Understood? We have to come to 2 to infinity 32 upon x cube, right? You know 32 is a constant. You can write x
Yes.
raised to
Yeah.
minus 3.
Mm-hmm.
X raised to minus 3 integration is what? X raised to minus 2 upon minus 2, right?
Yes, that's right.
Yes. So you will get minus 16. You know minus 16. X raised to minus 2 is what? X raised to 2. When you put infinity,
0.
yes, 0. And this is minus 1 over 4. That is 4, right? It
Yeah.
means this is,
Which is a
this is
4.
what? The value of this is constant. You can say the function is convergent. And you can see from the graph, the function is going to converge towards 0, right? Whenever you are
Yes.
going to infinity side, you will get the the line of this graph is converging towards 0, right?
That's right.
It is never perfectly going at 0, but it seems that the line of this graph is going towards 0. Okay, that's why this is called convergence, right?
Yes. Yeah.
And how divergence figure looks? It looks like this. Okay.
Okay. So yeah,
Yes.
it goes to infinity in the two sides.
Infinity or
Okay.
minus infinity.
Yeah.
Suppose you want to compute the value minus infinity to plus infinity. Okay.
Yeah.
This shows what? This shows minus infinity to 1. So first you have to go from minus infinity to 1. When the function goes from minus infinity to 1, its value is ex, right?
Mhm.
And when this shows
That's
what?
right.
From 1 to
From 1 to
infinity.
plus infinity.
And this is what e root ax. Okay. Okay. Minus infinity to 1. Here e is constant. E is any constant, right? This is root x. Root x is what? X raised to minus 2. Minus half. Integration of ex is ex, right? E is constant. This becomes 1 minus half plus 1 is half, right?
Yeah.
Okay. So this is what? Ex minus infinity to 1. This is 2e. This becomes 2e, right?
Yeah.
Put the value of upper limit, then lower limit. This is root infinity minus root 1. e raised to 1 is e raised to minus infinity is 0.
Yeah.
But there is a problem. Root infinity is what? Infinity. Infinity minus 1 is infinity. Right?
Yes.
E minus 0
Anything
is,
multiplied by
yes,
it's going
this
to be infinity again.
infinity plus infinity is infinity. It means that the
I see.
function is divergent. This is very, very important. You can note down this. Suppose a function is greater than 0 but less than other function gx. Okay. If fx diverges, if this is diverges, gx is also diverges. Very important. It means that if the function of if the limit of this function is infinity or minus infinity, then this is also infinity or minus infinity. Okay.
Okay, so again, this is a property saying like if we have a function
Yes.
greater than 0 and we have g which is greater than f, one becomes divergence, then becomes divergent.
Yes. If fx is diverges, this will diverges.
Still,
If gx is
f of g
converges,
is
then this will be converges.
nice.
Okay. It is not easy to prove, but very useful.
Nice. Yeah.
Very good question. How to integrate this? We will start from question number one. See how to integrate this. Here limit extends to infinity, and
Mhm.
I already told you whenever x tends to infinity, put t is equal to 0, and here 1 by t, right?
That's right.
Now simplify this. Take t cube common. You will get what? Minus 2t square plus t cube, right?
Yes. Yeah.
Okay. Whenever you are getting, okay, you can put directly t is equal to 0. When you put t is equal to 0, you will get what? 1 upon 0. 1 upon 0 is what? Infinity. It means that function is diverges, right?
I see. Yeah. We did. Yeah. Okay. So we are doing that active evaluation. Yeah.
Yes, right. Now you can see this. First put infinity directly. When you put infinity directly, you will get infinity upon infinity, right? Whenever you are
Which is
getting
infinity.
infinity upon infinity, what will you do? Just do differentiation, hospital rule, right?
Yeah.
Again, you are getting infinity over infinity. Whether you are getting infinity over infinity or 0 over 0, always use hospital rule, right? Again differentiate this. So in numerator you will get only 2. Now put infinity. When you put infinity, 0. So its value will be 0. Okay.
Yes.
Yes. But for this, here limit is what? Minus infinity. So 2 over x. When you put e raised to minus infinity, you know e raised to minus infinity is 0, infinity, right?
Yes.
It means that when you are going to left side, it will diverge. But when you are going to right side, it will goes to 0. It means that when you are going to left side, it is going upside. But when you are going right side means it is going towards 0. Okay, like this, right?
Yes.
Yes. What is this? Log. This is log 1 over w. When you put ln 1 over infinity, 1 over infinity is 0. Log 0 does not exist, right?
Log 0.
Yeah.
This is like a rule.
Yes. Okay. Here x square over x is there. How can you integrate this?
X squared over x.
Yes.
That would like simplify.
You can do simplify. Okay. So 1x cancel over.
Yeah.
Right.
Yes.
Now, how to draw the graph of this? This is
So
very good
usually,
question. The function is equal to 4 when the value of x is 1, 4 or 6. Let's
so
suppose
it's
this
not
is
like
0, this is 1, 2, 3,
it's
4,
what 1, 2,
5,
4, and 6.
6. Okay. So 1, 2, 3, 4, 5, 6. Otherwise 2. Otherwise 2 means even on minus
Straight
side.
line.
Yes. Okay. Now you can see the function is equal to 4 when the x is 1. Let's suppose this is 4. Okay. And this is 2.
Yes.
The function is equal to what? 4 when the value of x is what? 1,
4 and 6.
4 or 6. Otherwise 2. Otherwise 2 means other than this point will be 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2 Okay. Okay. Not only this point, even this point also will be 2. 1.5, 1.6, right?
So it's gonna be, yeah. So it's gonna be like a straight line.
Yes.
So,
It will be
yeah.
looks like this. Okay. So all this point it will be 2. But only at 1, 4, and 6 it will be at 4. Okay. Now the problem is how to draw the graph of this. You can draw like this. Okay. But at point 1, 4, and 6, it will be at 4. Okay. Understood?
Yeah, clear. Thank you.
Okay. Now how to evaluate from 0 to 5? What is the duration of your course? Data science?
Excuse me, what was the question? Sorry.
What is the duration of your course?
Actually, I'm not taking a course. I'm doing like some kind of research. So it's open somehow.
It's open. Okay. So you can finish anytime.
Yeah, that's right.
So when you see the graph, you are going to integrate from 0 to 5, right? From 0 to 5, you are going to integrate. But there are 2 points which are discontinuous at 1 and 4. So you cannot go directly from 0 to 5. First, you will go from 0 to 1. Okay. Then from 1 to 4. And then from 4 to 5. From 0 to 1, you can see the function is 0 to 2. 1 to 4 is also 2. And from 4 to 5, 4 to 5 is you will get 6. Okay.
Yeah.
Because at point 1, 4, and at 6, the point is discontinuous. Function is discontinuous, right? That's why we cannot go directly from 0 to 5. Right?
Yeah, it's clear. Thank you very much for explaining that.
Hmm. So many questions are there. Okay, now we will do question number 11. You can see you have to integrate from 1 to 8, but you cannot go directly from 1 to 8. First, you will go from 1 to 4, right? Because 4 lies between 0 to 4, right?
Yes.
And then 4 to 6. And then greater than 6 lies this 6 to 8, right?
Okay.
From 1 to 4, gx is root x. 4 to 6, gx is 3. And 6 to 8, 1 over x square, right?
I see.
Yes. You know root x integration is x raised to half. Half plus 1 is 3 by 2. Okay.
Yes.
Integration of 3 is what? 3x. Integration of integration of 1 upon x square is what? Minus 1 over x. Okay. Okay. 2 over 3. Put the value of x. 1 over x means 1 over 8 minus 1 over 6. When you do calculator, you get like this. Minus 1 over 24. Okay. 7 minus 1. 8 minus 1, 7. 14 over 3 plus 6 plus 1 over 24 plus 6. 173 upon 24. Okay, this is your answer. Okay,
Yeah.
it's very easy.
Makes sense. So,
Yes.
so I was wondering why you integrated to to 8, but I saw the yeah, interval.
Yes.
Integration of 1 to 8.
If you want to draw the sketch of this graph from 0 to 4, this is root x. Root x is what? It looks like this. So 0 to 4, right? This is closed interval. From 4 to 6, it is 3.
Straight line.
Y is equal to 3. Y means what? Um,
4 to 6.
Okay, when you put x is equal to 4, it is 2. It means that 3 starts from
Yeah.
here,
Discontinuous. Yeah. Yeah. I see.
right? 4 to 6.
Yes, that's right.
You can see this is a 4, okay? And this is 6. This is also open. Open on both sides, right? Because there is no equal sign. And this is closed, this is also closed, right? And from 6, this is 1 over x square. 1 over x square is what? X raised to minus 2. Okay?
Mhm.
So this is the graph, right?
Yeah. Yeah. Thank you.
Yes. No, no, yes, yes. Right, this is the graph. Okay, this is closed interval. Understood?
Yes, understood. So for 6, we take like the okay, because it's open and closed. So
Yes.
we take the
Open closed at 6 and open is infinity. Right?
yes. Yeah.
So today you understand everything?
Yeah, thank you very much. Appreciate it.
Okay.